Hi, in today's video, let's explore relational database transaction isolation levels, the I in ACID, which are the common properties of relational databases represented by atomicity, consistency, isolation, and durability. Understanding isolation is helpful, especially when dealing with concurrent transactions. By the end of this video, you will not only understand the theory, but also see how they work in action. I am using the latest version MySql 9.1.0 to record this video, and MySql default InnoDB as storage engine. Let's get started. In most relational databases, there are 4 different isolation levels: read uncommitted, read committed, repeatable read, and serializable. Adjusting the database isolation level can help balance performance and consistency. From left to right, consistency level is increased, but performance is decreased. MySql default transaction isolation level is repeatable read. In this video, I am going to cover read uncommitted and read committed isolation level and leave the rest in other videos. In order to understand what is read uncommitted isolation level, let's find out what is the issue with read uncommitted. That is dirty read. The screenshot comes from MySql official document. This is a definition of dirty read: an operation that retrieves unreliable data that was updated by another transaction but not yet committed. It is only possible with the isolation level known as read uncommitted. Let's jump into a practical example. I already have a MySql Docker container running on my local, and I have created a dummy balance table for this demo. This is what the table looks like. The initial amount value is set to 1000. First, set the transaction isolation level to read uncommitted. Transaction T1 tries to update the amount to 2000, then sleeping for 10 seconds. The reason I put 10 seconds here is because it is hard to make transactions concurrently. By sleeping transaction 1 for 10 seconds, I can easily create the situation just like concurrent transactions in the real world. At the end of the T1, it rolls back the update. Transaction T2 tries to read the balance in the meantime. T2 reads the amount of 2000, but this amount is never committed by the T1. It is a dirty read. Dirty read can be addressed by changing the isolation level to read committed. Let's see how MySql behaves after the change. T2 never reads the uncommitted value from T1. It always sees the 1000 amount as a result. Now, let's explore the read committed isolation level. Non-repeatable read is the issue on this isolation level. A non-repeatable read occurs when during the course of a transaction, a row is retrieved twice and the values within the row differ between reads. Let's set both transaction isolation level as read committed. T1 first reads the record, which should be 1000. Then T2 updates the record to 2000 and commit the update. After 10 seconds, T1 reads again. Let's run both of them and see how MySql behaves. As a result, T1 first read 1000, then changed to 2000 due to the update from T2. In a real-world application, be careful when we use this isolation level, because subsequent reads of the same row within one transaction might read different results due to the change made by the other concurrent transactions. In order to fix non-repeatable read, let's update the transaction isolation level to repeatable read and run again to see what will happen. Before we start, let's change this value back to 1000. After the change, T1 always read 1000, even after T2 changed the value within the execution of T1. Now T1 has consistent read. I will cover more details about repeatable read isolation level in the next video. In conclusion, MySql default isolation level is repeatable read. We don't need to worry about dirty read and non-repeatable read at the default isolation level. In common ORM frameworks such as Java Spring Framework, developers can change these isolation levels by code. I hope you have a better understanding about read uncommitted and read committed isolation levels.